Hi guys, so today we're going to go over the ambiguous case, which occurs when you have a side angle triangle, which means you're given two sides and one of its corresponding angles from the given sides. So for this particular problem, I created a flow chart for you guys so that you can follow along if there's one solution, no solution, two solutions that corresponds with this diagram as well, just to give you a better idea. So before we even start solving for the remaining sides and angles, we're going to test out, given a side-side angle triangle, if there is any solution at all. So what I'm going to start off doing is comparing side A and B. So side A is 12 and side B is 31. So 31 is greater than 12, which means we are here. A is less than B. So from that, we find the height, which is always the side that we don't have the corresponding angle to, times the sine of the given angle. So the height would equal to, in this case, B times sine of angle A, which would be 31 times the sine of 20.5 degrees. So first, make sure that your calculator is in degrees because sometimes for Module 5, it could still be in radians. So at the top of your scientific calculator, it should say DEG or D rather than RAD and R. Calculating this, we get approximately 10.86 meters. So what are we going to do here? Well, we're going to start comparing side A with the height. So side A is 12 and the height is about 10.86. So that means side A is greater than the height. So what would happen if it was less than? Well, this is what your triangle would look like if it was less than. It would be no solution because if side A was less than the height, that side doesn't have enough length to actually close it to become a full triangle. So in this case, we don't have that. We have two solutions, of course. So what does that mean if we have two solutions? That means that everything that is not given will have two solutions. So meaning there will be two answers for angle B, two answers for side C, and two answers for angle C. So how does that happen? Well, there's actually two triangles in one, as you can see here. There's two triangles in one. I'm not even going to try to draw that, but everything that's given are what the two triangles share. And then each one of these represents the angle from the first triangle, the angle from the second triangle. So it's just two triangles in one. So we're going to start solving. So we're moving on from here now that we've determined that there are two solutions. So I'm just going to kind of reiterate what we already know. This all has one answer only, and then everything that's not given will have two answers. So we're going to start off just the way we always would, even if this was just one solution. I'm given a side and a corresponding angle, so I'm going to start off with the law of sines. So A over sine of A equals B over sine of, we're finding the first angle for B. So filling in these values, we're just using law of sines. And then, just like the law of sines, we're going to cross multiply. So 12 times the sine of angle B sub 1 equals 31 times the sine of 20.5 degrees. And from here, I'm going to isolate the sine of B sub 1 by dividing both sides by 12. Make sure you have your calculators ready. So sine of B sub 1 will equal 31 times sine of 20.5, press equals after the numerator, and then divide by 12. and you should get somewhere around 0.9047. So from here, we're going to try to get angle B by itself. Now, sine and angles, they're stuck together. So what's the only way I can get rid of the sine is I'm going to use inverse sine. Whatever I do to one side, I do to the other. Again, make sure your calculator is in degrees. And to find the angle B sub 1, I'm going to take the inverse sine of the answer. Now, there was a whole decimal point with that answer. So if you take 31 times sine of 20.5 degrees equals divided by 12, you'll have that whole decimal answer. In your scientific calculator, press second sign, which will usually give you inverse sine, and press second negative, and it will bring up that whole decimal point for you rather than you having to type it in. And what you should get is 64.8 degrees. So we're going to put that up here. Now, how do I find the second angle for B? Well, and I'm, again, not an artist, so I'm just going to give you kind of a brief visual. Remember, there's two triangles in one. And what happens with angle B sub 1 and B sub 2 is that, and the two triangles, they create a straight line. So you can always kind of use this as the formula when there's two solutions. B sub 1 and B sub 2, they equal to 180 degrees because remember in geometry a straight line forms 180 degrees. Well, if I have angle B sub 1, which is 64.8 degrees, and I need to find B sub 2, and I know the sum of them equals to 180, then I'm just going to use my algebra and subtract 64.8 degrees from both sides and get angle B sub 2 equals to 115.2 degrees. All right, so from here we just have C left. Now, remember in the first triangle, we have side B, angle B. We have side C and angle C to find. So remember in the first triangle, if you have 2 out of the 3 angles, they add up to be 180 degrees. We know that in any triangle, the 3 angles will add up to be 180 degrees. So if in the first triangle, I have angle A, angle B, and I need angle C, in the first triangle, if I add those angles up, I should get 180 degrees. So angle A is 20.5 degrees, angle B is 64.8 degrees, and I can use that to find angle C in the first triangle, which I've named C sub 1. So adding these up and then subtracting it from 180, I'm just going to skip that step because I'm out of room. C sub 1 should give you 94.7 degrees. And you can do the same thing because, again, angle A is shared by the two triangles. We have angle B in the second triangle, and we're looking for angle C in the second triangle. So I'm out of room, so I'm going to move it up here. For the second triangle, A plus angle B sub 2 plus angle C sub 2 should also give me 180 degrees. So this would be 20.5 plus 115.2 plus C sub 2 equals 180 degrees. So taking the sum 20.5 plus 115.2 and then subtracting it from 180 degrees will give me my other angle, which would give me 44.3 degrees. So I am going to have to move on to the next page to find angle or side C. However, just because we have it all laid out here already, I'm going to use the law of sines to find side C. So I'm going to use side C sub 1 with angle C sub 1. You could either set it equal to b over sine of b sub 1, or you could set it equal to a over sine of a. It really doesn't matter which one. I always suggest you set it equal to the one that's given already. Remember, that was the one in purple, because if you made a mistake, let's just say we did make a mistake in B, it wouldn't carry on to the values for C. So I always say set it equal to the ones that are already given to you, but the choice is totally yours. So from here, moving on to the next page, I'm going to use A over sine of A equals C sub 1 over sine of angle C sub 1. And that would give me 12 over the sine of 20.5 degrees equals C sub 1 over the sine of 94.7 degrees. And then we're just going to cross multiply again. So we have 12 times the sine of 94.7. Sorry, my pen is acting up. Equals C sub 1 times the sine of 20.5 degrees. I want to get C by itself, so it's being multiplied to the sine of 20.5, so I'm going to divide both sides by the sine of 20.5 degrees. So to find side C, remember to plug into your calculator 12 times the sine of 94.7 degrees, press equals after that in the numerator, press equals in your calculator, and then press divided by sine of 20.5. And that should give you 34.15. Remember that this is a side, so the sides were in meters for this triangle. And last but not least, I'm going to go back for a minute. So we're solving for the side C sub 2. I have the angle C sub 2, so you could either set it to B over B sub 2, or I prefer to set it over A over sine of A just because it's given. So from here, we're going to do the same thing. We're going to take A over sine of A equals C sub 2 over the sine of angle C sub 2. So again, that's going to be 12 times the sine of 20.5 degrees equals side C sub 2 over the sine of 44.3 degrees. And we solve the same way, cross multiply 12 times. I'm going to split that up a little bit. 12 times the sine of 44.3 degrees equals C sub 2 times sine of 20.5. Sorry, I'm out of room. So from here, to get side C sub 2 by itself, it's being multiplied to the sine of 20.5. I'm going to divide both sides by the sine of 20.5. And again, from here, this is just all calculator, but remember to press equals after this numerator. I'm only saying that because sometimes, depending on the calculator, it will only take the sine of 44.3 and divide that by the sine of 20.5 rather than the product of 12 times the sine of 44.3. So with that, when you plug it into the calculator, it should give you 23.93 meters for C sub 2. And those are all the sides and angles. So again, that one's 23.93 meters. All right, guys, I know this was a longer one, but I do hope this helps.